Hello everybody, I hope you're enjoying VRDC. My name's Matt Newport and I'm the co-founder, CTO and up until now only developer of Osso VR. We're a small startup developing a VR surgical training application using hand track controls. My background's a software engineer in the video games industry and I've been super excited about the potential of VR ever since I backed the original Oculus Kickstarter. I left my last full-time game job 2 years ago to focus on non-games applications of VR or serious VR. I'm not sure what we're calling it yet. So I'm going to talk a little bit about some of the design decisions that you're going to face when you implement hand track controls in VR and share some of what we've learned over the last few months implementing hand interactions for our application. I'm just going to show you quickly a mixed reality video of my co-founder Justin, who is an orthopedic surgeon, to give you an idea what our application is all about. So after watching the mixed reality trailer talk, I feel slightly embarrassed about the quality of that now. So I'm guessing pretty much everyone here has probably tried some kind of hand track controllers in VR now, either the Vive or Oculus with a touch or the PlayStation Move. But I'd be interested, just a quick show of hands, who's actually working on a game or app that's using touch controls right now? Okay, so we've got a good number of people who've already got some experience here. So I don't think I need to spend any time convincing anyone who's tried hand track controls of how much immersion and presence they bring to VR experiences. At Osso, we really believe that hand track controls are hugely important for training applications, and having people actually physically perform the steps of a procedure with their hands has tremendous value for effective learning and retention. So the aim of this talk is not to convince you why hand track controls are a great thing. I'm just going to assume you're here because you already want to incorporate hand tracking, and I'm going to focus on what I think are some of the fundamental design decisions that you've got to confront early on when implementing hand track controls, and give you some tips and tricks from my development experience. And I want to spend a little bit of time talking about the surprising importance of throwing in VR and some of the challenges, implementation challenges, particularly for more complex hand interactions of the kind that we have in our app, with some specific examples. So one of the first questions that comes up when you're implementing hand track controls is how you're going to represent the user's hands in VR. There's basically two common approaches that people use. You either show some kind of virtual hand representation, which might be more cartoony like Job Simulator, or more on the realistic side like the gallery there. The other option is to show actual representations of the controllers, ideally the controllers you're actually using, so either the Vive controllers or the touch controllers. There's a number of examples of both approaches. Some of these screenshots are from games that have made different choices there. There's advantages and disadvantages to both. Showing controllers makes it really easy to have a true one-to-one mapping between the physical controller and what you're seeing in VR, and that avoids the possibility of any kind of immersion-breaking disconnect where the pose of your virtual hand doesn't match the pose of your real hand. It also makes it easier potentially to show new users the controls, because you can just indicate on the virtual buttons to show them what they should be pressing. Showing controllers then is definitely a good choice for a lot of apps. We opted fairly early on to show hands because we felt it fit better with the sort of surgical theme. So I'm going to focus on design decisions stemming from that choice. Most of what I'm going to talk about, though, it's actually not that important which of these you pick. It doesn't make that too much difference. So once you actually have hands in your game and tracked, the next thing you're going to want to do is start picking stuff up. And there's two main choices, regardless of whether you're using hands or controllers, really, of what happens when you pick an object up. You can either have the hand representation remain visible, or you can have it disappear and just see the object that you picked up. An animation is probably the best way to show the difference there. So on the left, this is from the gallery, and you can see the hand remains visible and is sort of posed to have a realistic grip on the object. On the right-hand side is the approach we've chosen, which is to have the hand disappear when you pick an object up. So showing the held object and the hand together might seem like the more natural, sort of obvious choice, but it does have a few downsides. It requires you to set up kind of preset grip positions for every object, which is more developer work. It also means that the visible hand position, what you see on the object, is quite likely not to perfectly match the user's real hand position on the controller, and that's potentially immersion breaking. You're also kind of forcing the user into a preset grip that you've chosen. You might choose more than one for a given object, but you don't give them the flexibility to kind of freely adjust their grip. And I'm going to talk a little bit more about why that's useful later. That actually can be a pro in some situations, though. If you have new users, having a freely adjustable grip can be a bit confusing for them. And if you've got something like a gun, which only has one real grip that makes any sense, then maybe it's simpler for new users to have these kind of preset grip positions. For our use case, though, we've definitely found that having a freely adjustable grip is the more flexible option for us. So having the hand just disappear when you pick an object up does seem a bit strange at first, but it does have a few advantages. It doesn't require you to do any special object setup, which is great for lazy developers like me. Users generally don't seem to mind, or sometimes even to notice, that their hands are disappearing, and they have complete freedom to adjust their grip. Disappearing hands can look a bit odd on video, but when you're in VR, most people seem to either not notice or find it perfectly natural. So this is a video from the gallery, again, just showing this idea of preset grip positions. So if you see when an object is picked up here, it kind of quickly animates to match the preset position and orientation relative to the hand pose that was set up by the developers. So that's perfectly good approach, but it does require some extra work, and potentially you might need to set up more than one grip per object, which just multiplies the effort. So the alternative, which I think maybe Job Simulator was one of the first titles I saw to take this route, is to just have the hand disappear when you pick an object up. It seems a little odd at first, but it's surprisingly effective, and yeah, users generally just don't even notice or comment on it. It seems that as long as when you pick up an object, it's still tracked perfectly one-to-one with your real-world hand movements, then your brain just kind of sees the object as a stand-in for your hand, and it doesn't break presence. So the guys who developed Job Simulator, the Alchemy Labs guys, came up with a nice term for this. I guess when they first started experimenting with it, they were doing a lot of picking up of tomatoes in the kitchen, so they call it tomato presence, and I think that's a pretty good term for it. So one of the next things you're going to have to confront with once you're picking up and moving objects around is what happens when your hand passes through a solid object in VR. So one of the kind of general principles in VR is that the hands in VR should always track one-to-one perfectly with your real hands. So if you have a situation where you pass your real hand through an empty space, but in VR there's a solid object there like a table, you don't generally want the hand to stop and separate the real hand from the virtual hand. That's, again, an immersion breaker and just can kind of throw people out of the experience. In some contexts that can work. I think we heard the Star Trek guys who are working on the Star Trek bridge title yesterday mention that it kind of worked in their case for touching touchscreens. But as a general rule, I think it's best to maintain one-to-one tracking for the hands and just let them pass through solid objects. So there's a related but sort of separate question of what to do about an object you're holding when you pass your hand through a solid object. And in our case, we do, again, I think what Job Simulator does, which is we break the object out of your grip when you pass your hand through a table. So I've got a video here illustrating that. If you've got an empty hand, you can just pass it through the table. If you pick something up, the mallet here, and try and pass that through the table, your hand will continue, but the object will just break out. And the way we implement that is using a Unity PhysX fixed joint, and we just set a break force on it. And that requires a bit of tuning. You want it so that it does break out of your grip when you pass it through the table, but not so easily that it just falls out of your hand every time you brush past an object in the world. And you also don't want it to be too strong or infinite, because otherwise if you go and hit objects on the table, the physics will kind of go crazy and things will fly all over the place. It's like a unstoppable object meeting an immovable force kind of thing, whatever that expression is. So that's something you might want to tune per object. That's how we have it set up, and something to consider. So I'm going to talk a little bit more about this grip choice stuff. So one of the downsides of showing hands and having these preset grip positions is that for certain types of objects, there are multiple different grips that might be natural depending on what you're planning to do with it. So with this example of a bottle of wine, if you're trying to pour a glass of wine, you're going to hold it differently from if you're just carrying it around, and differently again from if you're planning to hit someone over the head with it, which is quite a common scenario in a game. So you can handle that if you have multiple preset grips. You can just have more than one, but then you need some kind of logic to pick the right one based on some context, whether that's the nearest one to the user's actual position and orientation at the point they try and grab, or whether you try and infer from the situation which grip they're likely to use. It's just more developer work and more logic to deal with. So what we have is this, what I'm calling a flexible grip choice, where we basically just maintain the relative orientation of the hand to the object to the point you pick it up, and that lets you use an object in very flexible ways, as a croquet mallet in this case. Not that that's particularly useful for our game, but there are situations where that's valuable. So another place that actually helps out a lot is when you're passing objects from hand to hand, because you just maintain the object's position. It's not affected by passing from hand to hand. And it's actually a surprisingly common thing for people to do, and quite a natural thing for people to want to do when they're interacting with objects in VR, is just to pass something from one hand to another like that. And it's important to try and support that as naturally as possible. If people can't easily pass an object from one hand to another, they're likely to get quite frustrated. And if you have preset grip positions, you're going to have to kind of, when you pass the object over, it's going to have to pop or animate from one pose, the pose in one hand to the pose in the other hand, and that can seem a little unnatural. So one of the first things people want to do when you put them in VR with hand track controls is start throwing things around like a toddler. So even in a serious application like ours, if you disappoint the user's expectations and don't let them throw things, then you risk both breaking presence and inducing some combination of disappointment, frustration, maybe a bit of rage. It turns out humans just love throwing stuff around, so it's really a good idea not to disappoint your users by not supporting that. So throwing doesn't come for free out of the box in Unity. To get throwing that feels reasonably good, you do need to take something like do a bit of work in script, like take a moving average over a few frames of the linear and the angular velocity of the user's hand and transfer that to the thrown object as it's released. We also turn gravity down a little bit from the sort of default real-world gravity by about 20% to make it a little bit easier for people to throw and catch things. So the reward for a little bit of time tuning this stuff in Unity is you get a throwing experience that people seem to really enjoy, and that's great for demos. Even if we're showing our stuff to people who don't really care about the medical applications or the surgery side of things, they still have a lot of fun just throwing stuff around and making a mess. So it takes a bit of tuning, and I think we definitely still have some room for improvement with our implementation, but it's something I definitely recommend putting some time into, even if you think that your sort of serious VR application doesn't need throwing. So another thing that will come up, especially once you have throwing working, is objects falling on the floor. And something that's a really good usability idea is to have them teleport back to their starting point after a few seconds. Picking stuff up off the floor isn't any more enjoyable in VR than it is in real life. And especially if you're using the Rift and the touch controllers, it's quite difficult to get the cameras set up in a way that they have a clear view of the floor. And so often you'll find that users with the touch particularly don't have good tracking at floor level, which just adds to the frustration of trying to pick something up. The Vive doesn't usually suffer from that problem. You can actually generally get good tracking at floor level with the Vive, but it's still not much fun to rummage around on the floor for stuff that you've dropped. So it's definitely a good feature to add. So this is our implementation of that. So as well as detecting when objects fall on the floor, we also check for some other cases, like if someone's thrown something across the room and it's landed on a table on the other side of the room. We don't have locomotion in our demo, so if it's out of reach for the user, we'll eventually teleport it back. If physics kind of freaks out and goes crazy, as it does tend to do with hand tracking periodically, and objects just fly off with sort of infinite velocity into the ether, you want to detect that and have them pop back as well. The other thing that would probably be a good idea is to try and detect objects that get stuck inside of other objects due to collision issues. I haven't come up with a good way to handle that in Unity yet, but if someone can figure it out, I think it would be a good idea to do so. So I'm going to talk some more now about some more complex interactions we have once you get beyond just the simple things of picking stuff up and throwing them around. So for an effective training experience, we really want to simulate some more complex interactions. So we support a few of those right now in our current demo. So some of those are somewhat generic and reusable, things like attaching and detaching subcomponents of tools, screwing one part of equipment to another piece, or screwing in a screw or a bolt. we can kind of reuse those across multiple interactions. And then we have some others that are more custom, sort of special purpose for particular interactions. So for us right now, that would include things like drilling a hole in the tibia, hammering the nail in that you saw in the video at the beginning, and positioning the C-arm, which is this big X-ray machine that you can kind of move around. So over time, we're trying to build up a library of reusable common interactions, things like screwing, but we're also expecting that we're always going to have, for any new piece of equipment or new training module, there will be things that just have to be custom. So the next thing to think about is, when you're trying to create these interactions, is do you want them to be physics-based? So our experience so far of implementing interactions with Unity has been that PhysX, sort of rigid body collisions and joints, sometimes work quite well, and you can get a lot of stuff for free for your interactions without doing a bunch of custom scripting. But there are other cases where physics just breaks down. It's not robust or stable enough, and we end up having to resort to doing something in script, something a bit more custom. So disclaimer here, I'm not by any means a physics engine expert, and some of the physics problems that we ran into might well be resolvable if you're more of an expert PhysX user. I'm going to give some examples of interactions where physics did work out for us and where it didn't, and where we had to do something kind of faked in script. So the first one I'm going to talk about is the screwing interaction, which is where you're attaching one part to another using a screwing motion, or screwing a screw into a bone, say. So that's what it looks like, sort of our final version. This was my first attempt to get something like that working using a physics-based approach. So this is using a hinge joint, basically, in Unity. And initially it looked quite promising, and this seems to be moving kind of natural. You can see a bit of twitching around where it's supposed to be joined. Where this unfortunately broke down for us, and why we didn't end up using this, is when you try and turn it into a two-handed interaction, it just kind of turns into an elastic band, and we couldn't get the kind of a rigid connection there. I did try and tune and tweak a bunch of stuff in PhysX to get that to work the way we wanted, and I couldn't get a result that I was happy with. So the custom solution we ended up with uses parenting in Unity rather than physics, and then there's a custom script that does a bunch of funky quaternion math to try and produce something plausible based on the hand movements, while enforcing that constraint that we really care about sort of visually, which is that the two pieces are kind of locked rigidly together and only free to rotate around the one axis. The other thing we add in here, which is a good thing to include in general, is haptics that are kind of proportional to the local space rotation of the screw threads. So you get this thing like where every few degrees you get like a haptic tick, and it feels a bit like there's some resistance there, and it really helps sell the experience that there's some kind of physical interaction happening. So the next thing we're going to look at is drilling. In this case, we want to have constrained motion along a linear axis with free rotation around it. What's happening here is there's a thing called a trocar, which is basically a steel tube that you can place the drill through that constrains its path, and that's there because in a real operation you can't see where you're drilling. It's inside of someone's leg, so you want it to be guided by a piece of metal, and the same for the placing the screw into the bone here. So in this case, my first attempt was a collision-based physics attempt, and as you can see, again, the physics didn't get on too well there. This was just kind of a very twitchy, jerky experience. It wasn't very effective. He ended up giving up and hitting with that. So that didn't work out too well. So the next thing I tried was joint-based. So this is using a configurable joint in Unity set up to have one like linear axis and one rotational axis, and that works pretty well. It occasionally kind of glitches out if you really push the limits, but that's what we ended up using in the end, and I was quite happy with the result. So there's still a little bit of custom scripting involved there. We lock the drill onto this configurable joint that constrains the motion, and then as you're drilling, the script adjusts the limits of motion on the linear axis, so you kind of get this sensation that it's resisting as you go through the bone, and as you hold the drill down, you gradually make progress. And then when the drilling is complete, we make the joint breakable so you can take the drill out and remove it. So this is actually I thought was surprisingly effective, given that we don't actually have real, and haptics is a bit of an overloaded term, but the real resistance. You can't stop someone's hand or apply pressure on their hand. But the fact that when you're pushing against this, there is physics resisting the motion of the drill, and as you move your hand, the drill doesn't keep up with it. Gives you this sensation that there is some real-world resistance, even though there's nothing being applied physically. And if you push too hard, again, the drill will break out of your grip, and it's actually surprisingly effective. It works better than I expected, that you get the sensation that you're drilling against some resistance, and then when you break through the other side, we take the limits away and you can slide all the way through, and it's quite convincing, more than I thought was possible without kind of physical resistance type haptics. So I'm going to show you some hammering now. This is something that some people find a little disturbing. So our first try at this, again, was collision-based, and it had promise. This is kind of what you saw at the end of my attempt to slide it in, but it turns out that hammering kind of works better. The physics system just copes with that a little more nicely. We didn't end up doing that in the end. We went with a kind of custom scripted solution. That's something I'm considering revisiting. In theory, the physics-based solution could give you some nice stuff for free, like having the amount that the nail travels be proportional to the impact force that you hit with, but we, on a tight time frame, I just couldn't get it quite robust enough for what I was looking for, so we went with like a script that just detects the hammer blows and directly sets the position of the nail, and that kind of gave us the result we wanted without worrying about things blowing up in strange ways. But yeah, I think that one has the potential to be made to work using physics. So I want to talk a little bit about haptics and audio, and how when you use them together, they're kind of, the whole is greater than the sum of the parts if they're combined correctly in order to sell some of these interactions. So as I was describing the drill, even though we don't currently have any kind of technology that's consumer viable that can simulate any kind of physical resistance, so the drill example, or if you're hammering the hammer, there's nothing to stop your hand when you hit the thing that you're hammering. You can just move your arm through quite freely. But we find that once you reach a certain threshold of sort of presence or believability with the overall experience, you get to a point, it's kind of like the positive version of the uncanny valley, where your brain, or the user's brain, will just kind of start to play along with the fiction. It's almost like a suspension of disbelief thing from movies, where they will start to play along and even report sensations that aren't there. So we see that with most people when they use the hammer, they'll just stop their arm of their own accord at the point of impact. And if you have the haptic pulse together with sound effects that are placed correctly in space and timed correctly, and it all lines up with the visuals, people will sometimes report that they feel like an impact. And it's kind of surprising how much you can get from people just playing along if everything else is kind of tied up together. And haptics and audio that work well together is really key in selling that, I think. And as I said, some people actually will not complete the hammering of the nail. They find it too disturbing, which I think is kind of a positive sign that we're getting something right about that interaction. So the other thing I kind of already mentioned as well is haptics that are driven by real-world space and orientation, and respond to the absolute changes in those can be particularly effective. So I gave the example of the screwing motion, but there's things you can see in other demos, like if you're opening a drawer, and as you pull the drawer, perhaps every centimeter in real-world space, you get a little haptic tick, and it gives the sensation of there being kind of like I don't know, some kind of physical resistance as you're pulling it out. And again, that really just helps sell the physicality of the interaction. So I'm going to give a little shout out here to Newton VR. So if you're interested in experimenting with physics-driven interactions, hand interaction, definitely recommend checking out this open source Unity plugin. It's developed in part by two of our employees when they were at their previous company, Tomorrow Today Labs. All our interaction stuff is currently custom. We might switch to this in future, but when I started working on this stuff, I didn't know it existed. It's definitely worth checking out, though, and save you a bunch of time and look at some example code and see how some of this stuff works if you want to try it out. So a few conclusions. Hand interactions are a really powerful tool for training applications, we believe. If you make sure to get the basics right, so a lot of the stuff I talked about with think about how picking up works, deal with people dropping stuff on the floor, have throwing that feels reasonably convincing, and I don't think there are any absolute right or wrong choices for some of the design choices that I talked about, but what you want to do is be aware of them and think about what's right for your application. Custom interactions of the kind I was showing with things like the screwing, the drilling, the hammering, they can be pretty time intensive to implement, but the payoff, I think, is worth it. When those work well, they really help to sell the whole experience. And our whole sort of aim with this stuff is that we believe retention of things that people are learning will be more effective the closer to reality, and the more of their senses are engaged in the learning experience. So I think that can be a really valuable use of time. And physics for interactions, it's great and a real time saver if it works, but it doesn't always work reliably. I'm hoping that as hand interactions in VR get more common, we might start to see some of those things addressed by the guys building physics engines as they kind of adapt what they do to the needs of VR. But right now, it's something you have to really look at on a case-by-case basis. Just a few resources here that you might want to follow up on if you want to know more about this stuff. Alchemy Labs, the job simulator guys, gave a really good talk at Oculus Connect 2, which is up on YouTube. It's called Being There, Designing Standing VR Experiences with Track Controllers. There's a bunch of useful links on this kind of material at the site uxofvr.com. I post stuff periodically about hand tracking interaction on my blog. Feel free to email me if you want to talk about this. I'm always happy to chat with people. If you want to know more about our company and what we're doing, ossovr.com, and the physics package for Unity, interaction physics I mentioned, Newton VR, you can find that on GitHub. Tomorrow Today Labs built that. There's a couple of video credits there for the little videos I used to illustrate some points. And that's it. So I think we've got like 5 minutes for questions, maybe.
Hello.
Hey.
So we took a quick swipe at doing you're riding in a giant mech, like giant steampunk mech, where you're controlling via two handle things. Mm-hmm. And we had a really hard time getting people to keep their hands on the controllers. Like once stuff started happening, they'd turn to look at something and then let go of the controller or move outside of the range of the stick. And eventually what we did was we did like the ghost stick instead, like on mobile, where it just kind of like wherever you engage it turns to be the center axis. But I'm curious if there's any thoughts on how you keep people's hands in the right place when they're moving around, like on a virtual control surface, when they're moving around in like an action game.
So that kind of thing is definitely troublesome. Like I didn't mention it too much here, but any kind of two-handed interaction, you get a similar problem where people don't constrain their hands relative to position. If they're holding what's supposed to be a rigid object in two hands, then they're not going to have their hands stay in like reasonable places, and that's why the physics tends to go crazy under those circumstances. And the closest thing we have to a solution is this idea of your hand breaking away from the object and you making people aware of that with maybe a haptic pulse or an audio cue or both. And then so at least they're aware that it's happened. And then things like the screwing interaction, a bunch of the stuff that the custom script is doing is trying to guess at what people intend to do when they're trying to screw these two things together and respect the constraint that we care about, while at some point it just breaks down and you give up. But
Are haptics and sound strong enough to actually make people reach back and grab the virtual controller again?
So I don't know about that situation. We have haptics when an object breaks out of your hand because you passed it through a solid object too fast. People become aware of that, even if they're not looking at their hand exactly. They'll notice that, oh, I dropped it, usually. But yeah, there's not perfect solutions to that stuff, I don't think.
Hi, thanks for a great talk. And I have a question about, it's more about your testing of the effects of using hand interactions for teaching purposes. Mm-hmm. If you've done any studies where people did the same interactions but on a 2D screen without virtual hands.
So we haven't yet. We're setting up a study with UCLA where we'll basically train some surgical students in a procedure, both using traditional methods like reading an instruction manual or watching a video, and using our technology. And obviously the hope is that will demonstrate that they learn much better. We've got some confidence though, because if there is research out there from going back to the sort of 90s VR, and even outside of VR, just showing that learning is more effective the more senses that you can incorporate and the closer it is to the real thing. So I can't point you to direct research that relates to this, but there is a lot of research that supports the general thesis that the more realistic the training, the more effective the learning. So,
Cool, thanks.
Yeah.
One more. Have you played with the like the Daydream controller, the one they have out there that's all accelerometers?
Yeah, I haven't had a chance to try it yet. My feeling is that not having one-to-one tracking, it's going to be very hard to do the kind of fidelity of interaction that we're aiming for. I'd love to see that on mobile because it's so much more convenient for deployment and just even for taking around and demoing to people. But right now we haven't seen anything that we feel is like solving that problem in mobile. Okay, looks like all the questions. Thanks very much. And